All right, let's get right into it. Today, we're diving into one of the biggest, most important shifts in how we build, well, pretty much everything online. We're talking about the move away from these giant, tangled software blocks, what we call monoliths, to this clean, organized world of microservices. And trust me, it's way more than just rearranging boxes. It's a whole new philosophy. So you've got to wonder, right? Why are the absolute giants of tech, companies like Netflix, Amazon, you name it, taking their massive, successful applications and deliberately smashing them into hundreds, sometimes thousands, of tiny little pieces? What problem are they so desperate to solve? Okay, to really get this, we've got to start with the old way of doing things. And the best way to think about it is to imagine a restaurant with just one single kitchen for everything. And this visual just nails the concept. So on the left, that's your monolith. It's one massive, chaotic kitchen where the pasta chefs are bumping into the sushi chefs, everybody's fighting over the same stove. It's a mess. This is exactly how big applications used to be built. One single, gigantic, tangled piece of code. And running a kitchen like this leads to some serious headaches. You want to tweak the pizza sauce recipe? Sorry, you might have to shut down the entire kitchen just to do it. And what happens if the pasta station messes up? Well, that one mistake could bring the whole operation, sushi bar and all, to a grinding halt. And scaling is a nightmare. You can't just hire more sushi chefs if the real bottleneck is the single overworked pizza oven. So if the one kitchen madhouse is the problem, what's the solution? Well, you trade it in for something way, way better. The food hall. And this right here is the core idea of microservices. It's all about one simple concept: break things down. Instead of one monster application, you build lots of tiny, independent services that just talk to each other. And this is where that food hall model just clicks. See, each service is its own little specialized stall. The taco stand can totally change its menu, and the pizza place doesn't even notice. If the sushi bar suddenly gets a huge line, you can just add more staff to that stall without messing with anyone else. Each piece is independent, focused, and so much easier to manage. But okay, how does a digital food hall like this actually work under the hood? You can't just throw a bunch of services out there and hope for the best. You need some very specific, very cool tools to make sure all these little kitchens play nicely together. The first essential tool is something called Docker, or more broadly, containers. The best way to think of this is as a standardized, prepackaged, flat-pack kitchen stall. It's this neat little box that has everything a single service needs to run. The code, the tools, the recipes, all of it. Which means you can drop your taco stall anywhere, on any computer, and you know it's going to work exactly the same way every time. Now, if you've got hundreds of these little stalls, you need a manager to prevent total chaos. And that, my friends, is Kubernetes. It's the food hall manager. It directs the customers, tells new stalls where to set up, and when the lunch rush hits, it automatically brings in more resources. It's the conductor of the orchestra, making sure every independent part works together to create a seamless experience. Okay, so we've got the structure and we've got the tools, but this is where we get to the real secret sauce. Because this shift isn't just about a new way to organize your code. It's about a fundamentally different philosophy for how you even write it in the first place. And this new philosophy comes from a really elegant and powerful way of coding called functional programming. And it's so important because it completely changes how we give instructions to a computer. We move from this world of tangled complexity to one of clean, predictable results. In this slide just perfectly illustrates the difference. Look at the left side. That's the old imperative way. It's a super detailed step-by-step recipe. You're telling the computer exactly how to do its job. First, create an empty list, then loop through the old list. For each item, check if it matches. If it does, add it to the new list. It's exhausting. Now, look at the right, the declarative way. You just state what you want. Hey, give me the employees whose names start with A. That's it. So much cleaner, right? And here's the crucial link. Each and every microservice is designed to be like one of those beautiful declarative functions. It's small, it's independent, and it's laser-focused on doing one specific thing perfectly. Just like a function that only knows how to filter, or a food stall that only knows how to make amazing tacos. Okay, but this whole model of independent little pieces brings up a huge, critical question. What happens when one of them fails? If the taco stall runs out of guacamole, does the entire food hall just grind to a halt? Well, the answer, once again, comes from the world of functional programming. It uses this concept that has a kind of scary-sounding name, the maybe monad. But I promise the idea behind it is brilliantly simple. Instead of just crashing and burning when something goes wrong, a service just returns one of two things. It either says just, here's the result, if it worked, or it says nothing, if it failed. And that's the magic trick. This simple design prevents a single little hiccup from bringing down the entire system. The taco stand can gracefully put up a sign that says, nothing to serve right now, without shutting down the pizza place, the sushi bar, or anything else in the entire food hall. It's incredibly resilient. So, with all these amazing benefits, you might be thinking this food hall model is perfect, that it's the answer to everything. Well, not exactly. Let's wrap up by being real about the trade-offs. First, let's be absolutely clear. This isn't some niche, experimental idea. This is the architecture that powers the modern internet, period. From the Netflix show you're about to binge to the Amazon order you just placed, it's all built on a foundation of thousands of these tiny microservices working together. And this table really sums up the whole trade-off, doesn't it? That old monolith, the one kitchen restaurant, it's pretty simple to get started with, but good luck trying to scale it or update it quickly. The new microservices model, the food hall, gives you incredible scalability and speed, but the price you pay is complexity. Suddenly, managing all those independent food stalls is a much, much bigger job than just running one kitchen. Which leaves us with one last big question to think about. As our digital world gets more and more complex, woven together from an ever-growing number of these tiny, independent services, does this mean the future of all software is in fact small?